Hey, good evening. Good evening. Uh, yeah. Uh, I'm at a point where not quite getting enough inspiration for this. It's kind of slowing down a little bit. Oh, proof of gold by conjecture. Okay, so let's give it some different angle. Okay. We have learned a lot so far, but so uh, this was called Chebyshev theorem. It came from Bertrand's postulate. So Mr. Chev he proved this. So basically, it's saying given any number, it doesn't have to be prime. Okay, but any number and twice of that number in between, there's always at least one prime. Okay, so maybe we can kind of think in that context. Okay, so we have good box triangle here, and let's try to apply that Chebyshev's theorem here. Okay, so for example, eighth prime is in our convention. Eighth prime is 19. Okay, twice of that. You see the largest number is twice of that 19. 38. Okay, that's the largest prime. I mean, gold box number in this eighth gold box triangle, right? So between 19 and 38, let's see a number that's closest to 38, some prime number, okay? So between 19 and 37, yeah, of course you have prime numbers, right? That's the Chebyshev theorem. Okay. And one stairs down, one flight down, you have good G1 set, and you have 20 and 40 somewhere around here. Okay, so between that, yeah, that's prime numbers. Okay, all right. Because I'm thinking about density of even numbers. Density of even numbers. Okay, so between 20 and 40, how many gold box number here? One, two, three, four. Okay. Um, between 20 and 40, around, just around, one, two, three, four, five, six, seven, eight. So it's denser in vertical fashion than horizontal. One, two, three, four, five. One, two, three, four, five, six, seven, eight. Okay, so that seems to be always the case. And why is that? It's because boy. So intuitively, it's this. Okay, it's kind of like sieving Eratosthenes kind of concept where uh, I think we may be getting quite closer. Okay, we know up to prime get 8. We know, yeah, it's we kind of conceptually prove that. Okay, up to number 8, prime get 8. Yeah, the gold box triangle has complete coverage. Why? Because if prime gap is 8, okay, here you have 24th gold box number 90, 25th gold box number 98, okay? So 92, 94, 96 is missing. You can always find that right below. like 92, 94, 96. Why? Because first three primes are twos. First, first three prime gaps are 2, 2, 2. Okay, that's why you can always fill that up. Okay, so it does good box triangle have complete coverage. Just look down, down, down. Then you have complete coverage of even numbers. Okay, we know that much. Okay. Then somewhere down the line, this prime gap, I mean gold box gap or prime gap, just the same. G1 gap. Okay, it happens such that the gap is 14. Okay, and then we need to look at that. Okay, so yeah, let's take a look. Uh, I think it's this guy right here. Okay. Okay, it's partial gold box triangle. So so 109, 113, 127, they are the three prime numbers adjacent. Three adjacent prime numbers. Okay? So if you construct this partial gold box triangle, okay, you just add like one, then add two, 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 four, two. Okay? So between the G1 set 110 and 114, 4 is missing, right? I mean 112 is missing, right? That's easy, right? Between 113, 114 and 128, 116, 118, 120, and then 122, and then 124, and then 126. Okay, so uh, so yeah, sometimes you had previously when prime gap is 8, you can always find the missing link like below in that current column, right? But sometimes you have to look previous column, okay? Like in this instance. So the question is that always the case? Can we always find this missing link in somewhere in the prior gold box triangle? Okay, if we can prove that, then we are done. All right, so that's because that's equivalent theory, conjecture, equivalent problem. Okay, so equivalent proposition. Okay, so this is just out of luck that we found 122 here. Or is there some systematic reason? Did I write that down? using the maximal that maximal conjecture. I hope I did. Continuity maximal. Hmm. Boy. Uh, you know, let's make some more example. When prime gap is 10 and prime gap is 12, which comes later. Okay. Let's look at the table here. Okay. Mm. Oh boy. Prime gap, list of prime gap. Okay, so okay, it's not too far away. Okay, you're 14 and then 4, 6, 2, 10. Okay. We better grab a new whiteboard, okay? So, yeah. They say the next prime gaps is 4, 6, 2, then 10. Okay, so meaning, uh, yeah, we grab new whiteboard, okay? We're gonna study this, okay? Yeah. All right. Let's take a break, okay? Yeah. I just wanna drink some. Oh, it's so good. Oh. Mm. Yeah. Okay. Okay. So, yeah, we gotta grab new whiteboard, huh? Okay. Yeah, let's grab one. Uh, yeah, we'll erase this guy, okay? Yeah, I think I wrote this down. Iota function. Cute little function, right? Yeah. It's of theoretical interest, theoretical value, okay? Yeah, I can't correct it, okay? They are vectors, okay? So the ordering matters. So I wrote this down, okay? So we can safely erase this, right? Because we need some room. Yeah. It's always very difficult decision to pick a whiteboard to erase because, yeah. Okay. All right. I'm gonna put my socks on and. Okay. All right. Leg work. Here we go. Uh, I just copy from the list of prime numbers, okay? So I'll look them up. 109, 113, 127, 131, 137, 139, 149. There we go. Okay? So we have gap 10. Okay, so. Oh. Okay. Gap, prime gap 4, 14, 4, 4, 6 to 10, right? So 4, 6 to 10. Okay. Now, gold box number. Okay. So, G1. Okay. So we add 1 to this, guys. Okay. Then it becomes 110, 114, 128, 132, 138, 140, 150. Okay. So prime gap gets preserved because we are just adding one from the row above. Now, next gold box number. All right. Uh, okay. Well, let's just write it up. In our convention, first prime number is 1, second 3, third prime number 5, 7, 11. We don't need to go down too far, okay? So let's just stop there for now, right? And the prime gap, oops, I should have written prime gap in green. It doesn't matter, does it? Right? Yeah. Prime gap 2, 2, 2, 4. Right? Gold box number. Add 2. So 1, 1, 2, 1, 1, 4, and 1, 1, 6, 1, 2, 0. We need to do some more. Okay, alright. Just one more. 13. Gap is 2. So 1, 2, 2. 1, 1, 6, 1, 1, 8, 1, 2, 0, 1, 2, 4, 1, 2, 6. Okay. I made some mistakes. Okay. Okay. So when gap is 10, let's see the coverage. Okay. Uh, Between 140 and 150, there are, so 10 divided by 2, 5. 5 minus 1, 4. There are 4 even numbers, right? 2, 4, 6, 8, then, okay. So we found all the gap fillers, missing links, okay? 140 and 150, okay? So there are 8 numbers missing. 142, 144, 146, 148. Okay? Okay. It seems uh, when there are gaps that's bigger than 8, it seems like 14, for example, okay? Between 114 and 128, we found 116, 118, 120, and 122, 124, and 126. Okay? How about gap 12? How far should we go forward to find gap 12? I have list of prime gap numbers here. Okay. Yeah, Wikipedia, Oasis. Okay, yeah, I'm looking at both of them in two different web browsers. Okay, 46210, 266, 466, 210, 24212. Okay. Yeah, it's further down. So how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 12 numbers down. No problem. Out of curiosity, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Yeah, I see it. 199 and 211. So 199. You have 197, then 199 and 211. Okay? We'll take a break very soon, okay? So prime gap 2, prime gap 12. Alright? So this is the first occurrence of prime gap 14, 10, and 12. Okay? Let's write down the gold box number. Okay. Okay. Let's find the gap filler between 200 and 212. Okay, so you have 202, 204, 206, just like before, right? And then you have 208 and 210, just like before. Okay? That's it. Easy, right? Let's stop and think. Why are this missing link, the gap fillers are found so easily? Kind of wondering. I mean, it's good, but I want to understand why it's so easily found. So, in a given column, because prime gap, vertical prime gap is 2, 2, 2, 4, 2, right? So there's some continuity because you are adding 2, 2, 2, and then discontinuity because you're adding 4, right? Uh, but luckily for us, this horizontal prior prime gap is 2, so that's why we just need to look at previous column, okay? So minus 2 plus 4. That's how we get the continuity here, okay? Well, we're kind of lucky, right? Now, you have continuity like 4, 6, 8, 10, okay? 14, 16, 18, 20. And because the vertical prime gap is 4, there's a discontinuity, right? So how did we get 1, 2, 2? Well, minus 4, plus 4, plus 2. Okay, so, alright. So it kind of depends on the gap filler, where we can find it. It kind of depends on the prior prime gap. Okay, that seems to be the case. When the prior prime gap is 2, meaning it's like this twin primes, then yeah, it's easier because yeah. Let me look at more prime gaps. Okay, so we'll look at one more. Okay. All right. Because interestingly enough, next prime gap is also 12. 2 to 3. Okay. So take a breath, Ashton, okay? So, this is going to be a little bit challenging. Possibly. Okay. So, missing link between 212 and 224, okay? So 12 minus 2, I know, 12 divided by 2, that's 6. 6 minus 1, 5. There are 5 missing. 2 on 4, 2 on 6, 2 on 8. You see, yeah, it's more difficult, right? Yeah. Well, you just need more numbers. we take a break, okay, and then we find the missing link, okay? Yeah, we have to look deeper. All right, very good. This is fun. Let's take 5 minutes, okay? Very good. Okay, we're back. Let's take a look at this. Okay, I'm kind of excited because we finally found something that's kind of challenging. So, what's the point of doing this? Constructing gold box triangle. We want to observe and understand. Okay, we don't have to find a pattern per se. We just want to understand the behaviorism of these gold box numbers. Okay, so that's the value of the systematic enumeration method that we adopted. Um, so let me drink a little. Okay, so how about red wine? Very good. It's been a long time since I drank any red wine, so yeah, let's empty this bottle. Keeping my place tidy. Okay, gap filler hunting. We are hunting for gap fillers, missing links, like archaeologists, right? Yeah, missing link is archaeological term. The in the evolution, right, between species. Yeah, there's some missing links, right? So that's what we're hunting for. Something got in my eye, so I gotta flush it out. Okay. All right. So this is very interesting. Okay. So let's construct more vertical prime gaps. 13, 17, 19, well, let's see what happens. Gap is 4, 2, and yeah, I made mistakes. 19, then 23. Okay, let's see. Okay. 424. 424. All right. We need 220, okay? And we couldn't find it in the previous column. How interesting. Okay, let's look at even previous column, okay? So subtract 2 from the right column, okay? So there we go. Okay. Let's double check. 424. 424. Okay, good. So our missing link gap filler is like 214, 216, 218, 220, and then 222. Okay, so how interesting. We have to look like 2 columns prior, alright? So how interesting. Okay. Is it just a fluke? Is it, did we just get lucky to find this gap filler, or does it always happen? So that's the question we want to ask. Answer, right? That's the question we are asking. All right. How interesting. Okay. It shouldn't be that difficult. Okay. Why? Because um, when gap is, for example, gap is 12, prime gap is 12 between two adjacent primes, okay, like 211 and 223, right? Um, yeah, the G1 said we just add 1 to make it even number, okay? Because, why do we do that? Because Goldbach's conjecture is such that any even integer can be expressed as summation of 2 odd primes. Okay? So, yeah. What is gap filler? This missing link? Is some another number, Goldbach's number, even number, that is expressible as the summation of 2 primes. Okay? Column, row. Intersection, summation of 2 primes. Goldbach's number. Okay? So that's what we mean by gap filler or missing link. We want to find that inside of the prior Goldbach's triangle. Okay, if we always can, that's the proof. Okay, so I have a feeling we are getting quite close of proving it. Okay? Yeah. So, when gap is 12, okay, between 212 and 224, how many even numbers are there? We have formula for that, right? L, N formula, right? It's not log natural, no. We don't do that. We don't deal with logarithm, calculus, no, statistics. We don't, that's not our approach. It's some other mathematician's approach. We don't do that, okay? Yeah, there's prime number theory, right? I mean, prime number theorem, right? Has to do with prime counting function pi is asymptotically n over log n, right? Yeah, and according to that theorem, yeah, the corollary is that prime gap is about log n. Okay, so but we don't really care about those things because they are approximation or symptomatic behavior. So they are never correct. Okay, why? Because according to twin prime conjecture, it states there always will be twin primes no matter how big it gets. So logarithm doesn't quite work, does it? Okay, so but it's nice theorem. Okay, they proved it. So, but we don't use it. Why? I don't think we need it. Okay, so Chebyshev theorem maybe. Bertrand Chebyshev theorem maybe. Okay. So our methodology is systematic enumeration. Okay, so when gap is 12, okay, between 212 and 224, we have what 12 minus 12 divided by 2, 6, 6 minus 1, 5. We have 5 numbers missing. 214, 216, 218, 220, 222. Okay, so the way we found these numbers is this. Okay, 214, yeah, your prime gap numbers. Okay, uh, vertical prime gap numbers, horizontal prime gap numbers. Okay, so 212 next even number is 214, right? And 216, 218. Easy. Why? Because the first three prime gap numbers is 222. Okay? Now, next prime gap number vertically is 4. So that's why 218 become 222. And we are missing 220. Okay? You're not going to find 220 in this column. Okay? So we looked at previous column and we failed to find 220 here. Okay? Why? Okay, so go to previous column, minus 12, right? So you add 2, 2, 2 and then, did I make a mistake again? 2, 2, 2, and then 4, and then 2, and then 4, 2, 4 again. Okay, so 220 is missing still, right? Okay, then how about go one more back, and then we found it. Is it just out of luck? I don't know. Okay, or is it always the case? So that's the question we need to answer. How interesting. So whether we can find a gap filler or not, it depends on two things. First, the gap, current gap. Second, previous gaps. Okay. Uh, Basically, um, what we are looking at is this. Okay. We have this skip between two G1 number. Okay, 212 and 224, right? We have to find the missing links. And we have some difficult time because the prior gap number is 12, also 12, which is a very big number for a gap number, right? Uh, that's why it took us to go back and also back again to find this missing link, 220. Okay? Why? Uh, because, look at here. Gap is 10, right? So there's a lot of gap to fill, a lot of missing link to locate. But uh, because the previous gap number is 2, right? So it's like more dense. There's high density of Goldbach's number, okay? But when gap is 12 and also previous also 12, then there's a lot of jumping going on. So it's kind of sparse, so to speak. So statistically speaking, yeah, it's less likely that we can find all the gap fillers in the previous column, kinda. We are kind of conceptually getting it, right? So good, very good. I know it's amorphous nebulous right now, like in the foggy, but no worries, okay? We are getting better at it. Let's take 5 minutes, okay? We're getting better at it, so that's all that. And we are having fun, right? Yeah, well, at least I am. I mean, I'm sorry if you cannot read this very clearly, but you can still kind of see this, right? So, yeah. Very good. All right, we'll take 5 minutes, okay? I close this off a little bit for you, just a little bit. Okay. Better? All right. See you in 5. Okay, let's turn the heat up. Keep warm. Grab my blanket and get it started again. Let's get rid of all this hair. Okay. Now, let's take a break from mathematics, okay? Russian is very beautiful language, okay? You have this beautiful Russian names like Sasha, Natasha, Masha, okay? It's very beautiful language. Uh, yeah, I just looked up Professor Chebyshev, Gospodin Chebyshev, out of curiosity. He's he was Russian. So. 1990, I mean 1800 mathematicians. Okay, so old timer, old school. Okay. Okay. Let me drink corridor. Okay, so yeah, vodka is Russian drink too, right? So I'm studying Russian as well. Okay, so Gospodin, I finally got it memorized. It means Mister. Okay, so Gospoda, something like Mrs. I guess. I don't know. Anyways, uh, okay. So it's like a video game, two-dimensional video game, like Pac-Man or this Digger Miner, right? Back in the days, you dig a hole, find some gold. Yeah, there's gold in gold box conjecture, right? So of course, they used to have this award between I think 2000 and 2002. This publisher Faber and Faber they held this $1 million prize for anybody who prove or disprove gold box conjecture uh, in 2 years, and plus 2 years of publication. So, but nobody proved during that time. So, $1 million prize gone. Okay, so, but still, if you prove this, yeah, you prove it. Go ahead, do it, publish it. Okay, you'll be very famous for it. Okay, if I prove it, uh, I might try to publish it. Okay, because it's something very worthwhile. All right, then I become very famous. Okay, yeah, but we are kind of doing it together. Okay, so it's collective effort. Uh, so yeah, okay. I mean, yeah, you have 222, 218, 216. You have some gap fillers in the previous column, but it's not quite adding anything, right? Why is that the case? Because the only thing we couldn't find in the present column is 220, and it's not found in the previous column, so we have to look previous column. Okay, why is that the case? Probably it has to do with this twin prime. Okay, yeah. I hope I don't have to study this prime number theorem, okay, because that's quite involved. I hope I don't have to study that. I hope we can prove this without knowing, fully understanding prime number theorem, because that has to do with like Riemann zeta function and logarithm, and I don't want to study that. Okay, why? Life is short. Okay, so I'm not. I don't have huge interest in learning established mathematics. Okay, I rather make brand new mathematics. Okay, that's more fun. Okay, first in time, the sense of ownership, kinda. Okay. Uh, if we end up proving this, I'll mention you. Okay, and pay tribute to you for being a part of this. Okay, right. That's what I can do. Okay, yeah. Your moral support, yeah, it's very crucial. If we end up proving this, okay, if I end up writing a paper, yeah, I'll mention you, okay, to honor you, right? Let me grab a beer, all right? Maybe just take a breath. Yeah. Okay. Uh, so let's reduce this problem a little bit. Okay, so when gap is 12, okay, what we are trying to do is this. We need to express when gap is 12. Oh, forget it. When gap is 14, all right, we need to find even numbers between 114 and 128, right? So how do we find those even numbers? 114, 128, that's big number, right? Let's reduce the problem, okay? What we want to find is this. Watch. So we are looking for 116, 118, 120, 124, 122, 126, right? So when gap is 14, okay, we have two. Okay, meaning 114 plus 2, 116. 114 plus 4. Yeah, we are just looking at the delta difference. Okay? 114 plus 6. 114 plus 8. 114 plus 10. 114 plus 12. Okay? So we need to construct these even numbers. There are 6 of them. Why? 14 divided by 2, 7. 7 minus 1, 6. Okay? So those are the delta for missing links. Okay? What we need to do is construct these 5 even numbers, 6 even numbers using prime gaps. Okay? Yeah. 2? Yeah. 2. Okay. 4? 2 plus 2. 6? 2 plus 2 plus 2. 8? It goes like this, okay? Minus 4 plus 2, right? And plus 2, so minus 4, okay? Plus 2 plus 2, so it's now 0, right? And 2 plus 4 plus 2, that's 8. Okay, so that's how we got 8. 10, 2 plus 2 plus 2 plus 4, Yeah, that's 10. 12, 2 plus 2 plus 2 plus 4 plus 2. Okay? See? Yeah, we're get. I kind of feel we are getting very close. Okay? Just my gut feeling. We are reducing gold box conjecture into a equivalent problem that's a lot easier to prove. We came a long way. Okay? So, who knows? We may be able to prove this tonight. That'd be great, right? Who knows? It's possible. So yeah, the prime number theorem, it does give us some assurance, because at least we know from that theorem, the because I looked it up. Okay, the prime gap, its growth is kind of logarithmic, very slow growth. Okay, but the growth of gold box triangle is faster growth. Why? Because it's two dimensional. All right, its growth is kind of linear, kinda, because if you remember, gold box triangle is two dimensional, right? And the biggest number in gold box triangle is two times of n. N's gold box triangle, the biggest number is two times n. Okay, so it's kind of linear growth. Okay, so of course there are some gaps. It's not continuous. No. Yeah. But almost. Okay, so there's some gaps in gold box triangle. All right. Let's just express 8. Uh, Horizontal, vertical movement. That's the only thing we are allowed to do so. Okay, so 114 to 122, so plus 8. Okay, we did it by going backward, minus 4, plus 2, plus 2, minus 4. Okay, plus 2, plus 2. Okay, so you go that way, that way, that way. Okay, so that's 0 out, right? So then plus 2, plus 4, plus 2, 122. Okay, so it's kind of a jigsaw puzzle, whatever, right? Yeah. Pac-Man video game. So that's the only thing we need. Okay, you either go down or you go horizontally back or vertically down. Okay, that's the rule of the game. All right. If we can prove, okay, all this delta or between the two primes, these missing links, and delta of that, okay, if we can always express this delta, we call it delta, we just call it delta, okay. All deltas, we can always express this as subtraction and summation of prior prime gaps. That's the proof. So we are, this is our final, I mean, the latest, hopefully final, latest equivalent problem. Okay? We are reducing Goldbach's conjecture problem to an easier, then still easier problem. But while, in the meanwhile, we preserve the mathematical equivalence between problems. Okay? That's what we do. We came a long way, I'm telling you. So, what is this? Is this, okay? Can we express every single even integer, positive even integer, in terms of subtraction and addition of prime gaps? Can we always do that? Then we are done. That's the latest equivalent problem. Okay? I say it again. Let me take a break. Can we express even every single even integers there is with either subtraction or addition of prime gap numbers? Can we always do that? Then we are done. Okay? Yeah, kinda. Of course, you should use prior prime gap, right? But fortunately, this nice mathematicians, they prove that the growth of prime gap is very slow. All right, it's logarithmic. Okay, it's less than linear. You have x equal y, right? And you have y is equal to e to the x, and then y is equal to ln x, right? So logarithmic growth is slower than straight line. Okay? All right. Yeah. Let's do one more, okay? Then we'll take a break. So, for 212 to 218, it's always difference 6, right? Uh, how do we do that? It's like this, okay? So 6 was uh, minus 12, okay? Minus 2, okay? Plus 2, 2, 2, 4, 2, 4, 2, 4. Four, 4, 4, 12, right? Minus 12, minus 2, and then 2, 2, 2, 4, 2, 4, 2, 4. 4, 4, 4, 12. 2, 2, 2, 2, 2, 2, 4, 2, 4, 2, 4. 4, 2, 4, 2, 4. Let's see. Oh yeah, I'm sorry. It's 8. So it's not 6. From 212 to 280. I mean 220. Sorry, 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 sorry. It's 8. Okay. Yes, yes, yes. Okay. That's how we came from 212 and we arrived at 220. Missing link. Alright? And difference between them 8. Okay? Yeah. So can we have to stay in the gold box triangle still, okay? So the rule, uh, you can go back horizontally and you can go down vertically, but you have to stay in the gold box triangle. Can we always express all these deltas by doing this? If we can prove that, then we are done, okay? So, yeah, good. Let's take 5 minutes, okay? All right. Very good. We're making very good progress here. Yeah. Yes, so systematic enumeration method, it works. Okay, so yeah. Okay. We are making good progress, just little by little, right? Yeah, I mean, we are able to reduce Goldbach conjecture problem to a lot easier problem to prove, right? Yeah, this gap deltas, prime gap deltas, just continuous, relatively small, even integers. Okay, can we always express this deltas, gap deltas? We call it gap deltas. Okay, this gap deltas, relatively small, even integers. Can we always express that as in terms of subtraction or addition of prior gap numbers? Okay, if we prove that, then we are done. Okay, good. That's a lot of reduction. It's a lot easier problem to prove. Okay, so to solve, we'll name this. Okay, gap delta conjecture. Okay, gap delta conjecture is equivalent to Goldbach's conjecture, right? So we're not going to do any proof. We don't have time, right? Once we conceptually prove this, then we'll go back and prove every single intermediary equivalence between this conjecture, that conjecture. We'll prove that later, okay? Because as long as you conceptually prove something, to formally prove that, it's just language translation. It's mechanical. It's not difficult at all, okay? So let's conceptually prove this first, and then we'll formally prove later. Okay? All right. All right. Let's take a breath, shall we? It's kind of getting chilly here, so. But night is still young, okay? So, yeah, I'm running for president, okay? Why? Some of those weird, strange hobbies of mine. Uh, if you don't vote for me, if you vote for X Vice, Mr. X Vice Joe Biden, trying to rhyme, okay? So, or if you vote for incumbent President Trump, I wouldn't blame you, okay? It's your right. They have more chance to get elected than me, so you don't wanna waste your voting contribution. So yeah, it's understandable, okay? But I'm running, okay? Why? As a protest. I think I can do better than both of them combined, okay? So, yeah. What can I tell you? Okay. So what we observe is this, okay? 211 was the index of their prime. Let's see. Ah, boy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oasis is too low tech. Okay. 'Where's my rose hips? 45th. Okay. No, no. 47th. 211 is 47's prime number. Okay. Now, to find all the gap fillers between 211 and 223, I mean, between 212 and 224, we only need to look at nine rows and three columns. Okay? To find the gap numbers at 47th prime and 48th prime, what we need to look at is 9 rows and 3 columns. Okay? Which is relatively small number, right? Compared to 47, number 9, number 3, that's easy. Okay? Because it's like that because according to prime number theorem, the prime gap grows in a logarithmic fashion, very slow growth. Okay, so yeah, okay. It didn't take us very long before we found all the missing links. We just looked at 9 rows, 3 columns. That's all it took to find every single missing links. Okay. So that's why I'm telling you to prove this gold box conjecture, it shouldn't be that difficult actually. Okay. Uh, yeah. We may be getting very close to proving it. Okay. I'm playing this role of Moses. We are in a desert, right? We are going to the promised land, the proof of gold box conjecture, where this we can find milk and honey, right? Kinda. Okay. Right. The land of milk and honey, huh? Well, we just want to prove it, right? Yeah. I mean, yeah. because I'm currently already in milk and honey land. Okay, me living in Alaska, and I have a loyal job that I enjoy. So yeah, I'm satisfied with what I have now. But it'd be nice if we have, if we prove this, then if I publish this, prove this, and publish this before you do, okay, then I become famous, and I'm going to use that fame in order to publish more articles, like this proof of Mr. Einstein's special general relativity. Okay, because if I publish that first, nobody gonna take me seriously. Okay, but if I publish Goldbach's conjecture, if we do, then I will get some credit. So they will take me more seriously. Okay, and then I can publish more articles, like this proof of Einsteinian relativity, both special and general. Okay, because by then I have some credibility. Okay, step by step, right? And then I will publish articles about climate change. Okay, because that's something a lot bigger than nowadays the special relativity. Okay, so Einsteinian relativity. Okay, so that people can take me more seriously. Okay, yeah. Climate change. What's about it? Yeah. There's nothing to worry about. Okay, so that's something I can publish, right? So that's what I mean by promised land. All right. So uh, let's take 5 minutes. Okay. Yeah. All right. We'll take 5 minutes. Oh, Yeah, we are traveling, right? Metaphysically, mathematically. It's a long journey, right? Yeah, yeah. We're enjoying this journey, so it's good. Uh, uh, yeah. I have to refer back to this guy. Um, okay. So, yeah. During the cigarette break, I some idea came to me. Okay, so what we're gonna do is we're gonna construct another triangle, and we give it a name. Prime gap coverage matrix. Okay. When I was in Wisconsin, Madison, Wisconsin, about 2 decades ago, there's this radio advertisement. It's like about, you know, human resources job finder kind of, and their slogan was long name, amazing result. Okay, so very catchy. Right. Yeah. So yeah, prime gap coverage matrix, long name, amazing result. Okay, so okay, let's write out prime gaps. Okay, and see coverage of that. Uh, we need more room, right? Prime gaps, okay? Because we only need to prove this inequality, okay? Like subset relationship, like if you remember, the maximal, uh, continuity maximal, okay, of this leap set, missing link set, maximal of that is which is like the next prime minus one, okay? So that's always less than or equal to, most likely less than maximal of the previous Goldbach triangle. Okay, continuity maximal thereof. Okay, so it's inequality. So I don't think it's necessary that we have the closed form formula for prime gap. Okay, so it shouldn't be that difficult. Okay, as far as I can see. So 4242 4626. 4626 42466 26426 468. Okay. Systematic enumeration method. It always was 424246. 42466. 6426. Yeah, we don't have enough room. That's fine. Uh, you're 466 2642. Uh, yeah. Yeah, that's all we have. Okay. We don't have any more room, so let's give it index. Now I'm getting hot. Oh boy. Okay. 222424246. 222424246. 26424. 26424. 6626. 6626. 42. Okay, okay. Let's give it index. First gap number. Okay. Okay. Whew. Now we have to add them up. Okay. Oh my goodness. Systematic enumeration method. All right. It's very laborious, labor intensive kind, but it always works. Okay. It has always worked for me. Okay. We are looking at continuous coverage of even numbers. Okay. Yeah, we're looking at from different angle basically. Okay. So. You're adding two. Okay, so adding x and y basically. Okay, so yeah. Ay. Very boring triangle actually. It grows so slowly. Whatever. Two and this guy. Okay. it should be identical, right? Yeah, 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 yeah. Whatever. Now we're adding 4, so it's adding 2 to these guys. Yeah, we don't need that. Okay. Now we're adding 2 again, so let's just. Are we missing something? I feel like I'm making some mistake here. Because I'm not quite being productive here. It's too much repetition, right? What am I doing wrong? Yeah, I think I got it wrong. Okay, I mean, we have to design this matrix, okay, in a more productive fashion because this is way too repetitious. All right, so let's design this. All right, because we can do a lot better than this. All right, so okay. Uh, Basically, it's this. All right. You have 0 here. Okay, so 0 plus prime gap set, 2 plus prime gap set, and we are adding 2 to the previous row. It's probably that's better. All right, so hmm then it's quite not quite symmetric matrix anymore, huh? Okay, that's fine. All right, let's do it. Just add two, okay? So to the previous row. Yeah, I know it's boring, right? Yeah, but that's the way it goes. Add two again to the previous row, right? So we have 1 hour left. Yeah, I can see the time in the screen, so on the screen. Because our latest conjecture is that latest equivalent conjecture is that the gap delta can be expressed as summation of or subtraction of previous gap numbers. Okay, so that's why we are doing this. We want to see the coverage of summation of prime gaps. Okay, does it give us continuous coverage of even numbers? Okay, if so, how far? Okay, that's what we're trying to find. Now, next, add four. Okay, yeah, I'm sorry, it's too boring. Okay, but there's no other way. Okay, just the way it is. Mathematics not always exciting. Sometimes very boring. Okay, so yeah. Now add two. Very humbling experience. Like cleaning the bathroom, kinda. Right. Okay. Let's stop and think. All right. Let's see some. Let's see if we can find some patterns. Okay. Wow. Shoot. Oh boy, this such a labor intensive activity. Let's look at coverage, all right? And let's relate this with the gold box triangle. Okay? We'll look at it like this. Alright? We look at square. Okay? Forget about this first column, okay? Square. We have 2. Second square, 2, 2, 4, 4. Third square, 2, 4, 6. Fourth square, 2, 4, 2, 4, 6, and 8 and 10. Fifth square, uh, 2, 4, 6, 8, 10, 12, 14. Sixth square, all the way to 16. Complete coverage of even numbers, okay? I think it's worthwhile repeating. Okay, yeah, let me write it all down. Okay, so it seems to have nth square seems to have complete coverage of even numbers. Okay, so it's worthwhile the effort. So interesting. I told you, systematic enumeration method. Yeah, it's laborious, boring, but it does pay off. Okay, so getting chilly. So it will pay off. Trust me. Okay, I promise. I promise. You know, in Matrix, Morpheus says, "Where others failed, thou shalt succeed." Right? Yeah. Who knows? We may succeed. So again, you know, if I end up publishing before you do, what do I have to offer you? Yeah, I honor you. Okay, you know, full note. All right. So yeah, thank you for being with me, and that's what I can offer you. Okay. Yeah. By all means, prove this before I do. Okay, and publish it before I do. Okay. Just acknowledge that you are inspired by somebody else. That's all I'm asking. Okay. So yeah. So we have 36 here, okay, but it's way back here, way forward. But to make 36 closer by, yeah, it's not that difficult. We were adding 2 down there, so we see 36 very soon, okay? Here, you have 36. Okay? Because it's two-dimensional expansion, right? X plus y become diagonal. It's like vector summation, right? Yeah, that's why you don't have to go all the way here to get 36, no. Because you're expanding both x and y directions, so that's why. That's the conceptual basis that Goldbach's correct integral is probably true, okay? So because Goldbach's triangle is two-dimensional, okay, as opposed to one-dimensional, so it should have more coverage than this lip prime gap, right? So, yeah. Okay, add two. Now you have 38 there, but here you have all of a sudden 38 as well. Because lip prime gap is 6, okay, so, alright. Okay. I mean, maybe later on we need to see the gap between the prime gaps. It's kind of acceleration concept, right? Prime gap is kind of relative speed between primes, right? Uh, and gap or prime gaps takes kind of acceleration, like second differential, right? Like you have dy dx, you have acceleration, your second derivative, like d squared x, dy squared, something like that, right? Yeah, we may need that. I don't know. Let's keep an open mind, okay? So we'll take a break after this row, all right? My fingers are getting tired from all this riding. It's like snow blindness, you know. We may be witnessing history in the making, okay? Possibly, if we end up proving this. I want to do one more, okay? We have 44 there. I want to see 44. Uh, okay, we'll take a break, okay? And we'll see some pattern, okay? To see, does this nth square does always give us, always, continuous coverage of even numbers, okay? Or are there some skips, jumps, just like in Goldbach's triangle? Goldbach's triangle, yeah, there's some missing gaps there too. Okay. Well, yeah. We'll take 5 minutes. Okay. Very good. Very good. Woo. Woo. let's take a break from mathematics, okay? Ah. So in Korea, this this amazing food called mandu, okay? It's basically dumpling, okay? Chinese, China, Japan, they have that, right? Oh, I love that food, okay? Dumpling, so good, right? But believe it or not, yeah, I can buy it here in this town, okay? Yeah, they have some dumplings, but they're kind of expensive because to make a dumpling, it's labor intensive. Okay, so their prices. So, but I love dumplings, man. Oh, mandu. Oh, yeah, I do miss certain things in Korea. Okay, Korean food, but fortunately enough, they make Korean food in this town too. There's Korean restaurant here. Okay, so they're very good. Okay, so yeah. Now let's take a look. Even number coverage by adding prime gap numbers. Okay, so 4th square 2, okay, 2nd square 2 2 4 4, 3rd square 6, 4th square 8 and 10, 5th square 12 and 14, 6th square 16, 7th square 18, 8th square 20 and 22, 9th square 24, 26, 28, 10th square 30, 32, 34, 11th square 36, 12 square 38, 40, 42. It does give you complete coverage of even integers. And it's accelerating. The brand new even integers, this nth square covers, actually speeding up. And it's completely continuous. Good. I told you we are getting very close. Okay. Let's finish up this. I don't feel like, you know, let's just do it. I told you, the systematic enumeration method, it always pays. Okay. It's kind of a surprise to me. All right. Gives you nth square in this uh, prime gap coverage matrix, nth matrix, square matrix. It gives you complete coverage, continuous coverage of even numbers, which is quite surprising to me. Okay. We'll take a break, and I'm gonna finish writing down. We are almost there. All right, so I can feel it. I'm quoting from this X-File episode. It's about weather forecaster, meteorologist falling in love in this kind of midwestern southern town. I think it was in Texas. I think, I don't know, somewhere. Okay. So X-File episode. Okay. Let me have some Toms. Oh, okay. So I want to drink. We'll just observe. We'll write it all down and observe whether it gives us complete coverage or not of even numbers, this nth square matrix. And if it does, we'll then think about why it gives us complete coverage or even in numbers. Okay, but first we need to observe, and then we'll think about why. Okay, and then we'll formally prove it. Okay, and then we'll conceptually prove it, and then we'll formally prove it. Okay, so after that, we make some connections between conjectures, equivalence thereof. Okay, so we are like divers, right? We took a breath. Now let's go under the water again. Okay. Because divers in Asia, including Korea, they have divers, and many times it's mature females. Okay, in like Jeju-do, yeah, all the females they dive to get those edible seafood. Okay, yeah, old school. No oxygen tank, no, just holding the breath. They're hardcore. Okay, older females in Jeju-do in Korea. It's an island, south of South Korea. Okay, hardcore people. Okay, old females, divers. They dive without oxygen tank by just holding the breath. Okay, Hawaiians, traditional Hawaiians, they do that too. Edible seafood, right? Like oyster, clams, shellfish, sometimes octopus. Hmm? Yummy, yummy stuff. You know, I when I was living in Los Angeles, California, I sometimes went to Tijuana. Okay, don't ask me why. I'm not in allowance. I'm not in liberty to tell you why. Okay, because I have to watch my mouth, right? So probably you know why, right? Yeah, but there's no need for me to spell it out for you. Yeah, I went to Tijuana. Okay, and they have this seafood cocktail. Oh my goodness, so good. Pulpo. Oh, pulpo. Octopus. Oh my goodness. Shrimps. It's so fresh, and they have this freshly cut coconut. Just cut it off and stick a straw. Coconut milk. Oh my goodness! And after I'm done drinking this coconut milk, uh, they chop it down for me. This meat of coconut, this in lining. Yummy. So good. Amazing. Authentic Mexico taco. It's melt in my mouth. And when I was in Los Angeles, I lived in this uh, town called NoHo, North Hollywood. They have this fantastic authentic taco stand on the street, on the corner in my neighborhood back then. Authentic, like taco langua, cow tongue taco. Melt in my mouth, man, mouth watering, and they also cook this cebolla, onion. They don't cut it. It looks like an egg, right? They just grill it as it is. Taste of heaven, man. Amazing. In Alaska, in this town, we also have some Mexican restaurant. Some of them are really good. Oh, let's get back to this. Let's dive. Ah! Yeah, I miss certain things in California, Los Angeles, California. Okay, taco stand, amazing. Yeah, my Mexican neighbors. It was mostly Mexican, Hispanic neighborhood. Oh, they're also nice to me. Okay, they're fantastic people. Okay, so. Fantastic cooks. Even in Alaska, we have some Hispanic population, and they're very nice to me. Okay, I have many friends here, Hispanic friends. Yeah, they're amazing. Let me turn off the heater. Oh, it's getting too hot. Oh, you're so sensitive. Yes, I am. I'm sensitive to temperature. Very sensitive to temperature. Okay, so maybe that's why I never get sick. Maybe that's why I'm always happy. Okay, because it's too hot. Yeah, I take my layers off because happiness has to a lot to do with temperature. Okay, if you're too hot, too cold, you're not happy. Okay. Okay. If you're too hot, you get angry. Okay, so regulate your body temperature. Okay. So I was watching last night after recording this Twilight Zone series episode. Uh, it was a mannequin. Okay, so and this lady asked to ask another lady, "Are you happy?" And the other lady was like, "Excuse me? What? Am I happy?" I said, "That's none of your business." It was so funny. Ah, Twilight Zone series. I love Twilight Zone series. Black and white, right? Just by the story, original story. English literature, right? Yeah. But they're very well learned people. So black and white. 1960s, 50s. I think 1960s. I think. Okay. So not much special effect. Okay. So how about Charlie Chaplin? Right. The story itself. Today's Hollywood movies, okay, too much special effect, but not many good stories, right? You know, let me finish this, then we'll talk about Hollywood movies, okay? Even some Korean movies as well. Let's finish this. Let's get this over with. Alright. Whew. We have about 20 minutes left, okay? We may as well just continue, alright? So, keep going. People may say, what kind of dumb mathematician is he? He's not even a mathematician, he's just adding numbers. So dumb, so ignorant, so low tech. Nah. But in my experience, systematic enumeration method has always pays. Has always paid. It always gave me good results. Okay, so in my experience. It's pain in the case though, I know. Good that we have water. You have Route 66 right there. Okay. I have driven on that road between what? California, Arizona, I guess. Historic Route 66. Yeah, I've been driven that road. Route 66 again. I went to this Amsterdam, Netherlands, okay? Again, don't ask me why I went there, okay? Yeah, I traveled there. Backpacking, Europe. So I went to a bar, right? And then talked to some locals. And they have this sign, as a decoration. It was Route 666, okay? That was funny. Yeah, it's some joke. Well, now 70, okay. 68, 70, 72. Yeah, thank you for being with me, okay? If you can, go ahead, prove this, publish it before I do, okay? I have no problem with that. Why? I kind of want you to actually. Why? Because I want to publish this? Oh, that's too much work. I'd rather have you do it, okay? 74. So I did my job, come on, okay? Why not some division of labor, huh? Yeah, go ahead, prove this formally and publish it, okay? Do I really want to do this myself? Formally prove it and publish it? I'd rather not, okay? I have better things to do. We gotta talk about economics and stuff, linguistics. Okay, we have to compensate for this 200 lost episode, right? Yeah. I may just leave it to you, okay? So, if you formally prove this and publish it, I'll be very proud of you, okay? So, by all means, okay? Just acknowledge that you got inspired by somebody else. Okay, that's what I'm asking. Okay, you don't have to mention my name. Cite this website. If you want to, you may. I give you permission. All right, but yeah, just don't steal it. Okay, just acknowledge some contribution from us. Okay, that's what I'm asking. Yeah, just say in a footnote you got inspired by somebody else. Okay, that's what I'm asking. All right, so I'm easy. I'm very easy. 78. Finally, last row. 78. Very humbling experience. 80. Okay. We'll take 5 minutes. Okay. Oh. It's not a proof yet. Okay. Just leg work. Labor intensive. Alright. You will pay. Okay. You know, let's stop this episode. Okay. And we'll take 5 minutes break and we'll just restart. Okay. See you soon.